What's up, everyone? We're going to do part 1 of a trigonometry review, so let's get into it. All right, our example 1, the following diagram shows a circle with center O and radius 40 centimeters. Points A, B, and C are on the circumference of the circle, and angle AOC is 1.9 radians. We're first finding the length of the arc of AB. So my arc itself is measured in radians, so that means the length formula that I'll be using is just the radius times the angle, which means I'm doing 40 times 1.9 and getting 76 centimeters. Part B, finding the area of sector AOBC, so finding the area of this sector. Again, since I'm measuring, or my angle is measured in radians, I'll be using this formula and subbing in what I know. I know my radius is 40 squared. I know my angle is 1.9. And putting that into my calculator, I get 1520 centimeters squared, or 1,520 squared centimeters. All right, example 2, 3 airport runways intersect to form a triangle, ABC. The length of AB is 3.1 kilometers, AC is 2.6, and BC is 2.4 kilometers. A company is hired to cut the grass that grows in triangle ABC, but they need to know the area. So they're first asking us to find the size in degrees of angle angle BAC. So we're looking for this angle. Since I have my 3 sides, that means we'll have to use the cosine rule. So I'm looking at cosine of A equaling, it's going to equal B squared plus C squared minus A squared all over 2BC. Remembering that this is side A, this is side B, and this is side C. So I'm going to sub in what I got. And remembering that this fraction equals the cosine of A. So when I go to my calculator or Desmos to evaluate this, I'll have to do the inverse cosine of that whole fraction and making sure I'm in degree mode. And when I do all of that, I get 2 3 sig figs, 48.8 degrees for angle A. And part B, finding the area of triangle ABC in square kilometers. Since I just found angle A, instead of using the exact formula that's given to me in the formula booklet, I'm going to switch up my letters a little bit here. So I'll still use the 1/2, but since I'm using angle A, I'm going to focus on side B and side C, and then the sine of angle A. So again, I'll sub in what I know and then go to my calculator. When I put this in my calculator, again, I have to remember I'm in degree mode since the angle I found is in degrees. And when I do that, I get 3.03 square kilometers. All right, and finally, example 3, a flat horizontal area ABC is such that AB was 100, BC is 50, both in meters, and angle ACB is 43.7 degrees, as shown in our diagram here. For part A, we're showing that the size of angle BAC is 20.2 degrees, correct to 3 sig figs. So remember, show means you need to show all the work. They're telling you this is the answer, though. So when I'm looking at my diagram here, I notice that I'm given angle C and side C. So that tells me I can use the sine rule. And since I'm basically looking for angle A, I'm going to use the A information set equal to the C information. So let me plug in what I have and we'll go from there. So you actually have a couple different options of how to show that angle BAC is 20.2. You can pretend like you don't know what that is and find angle A by cross multiplying, solving for A, and then going to your calculator. So if I do it that way, I would be plugging in this right-hand side into my calculator. I cross multiplied, I did the inverse sign of that fraction since I'm looking for the angle. And that will show that I'm getting angle A to be 20.2087. Or to 3 sig figs, the 20.2 degrees they told me it was going to be. You could also, from this step, instead of just leaving A, you could sub in the 20.2 and just verify that left-hand side equals right-hand side. When I do that left-hand side, I get 144.74. Right-hand side, I get 144.08, or sorry, 80. So while they may not be exactly the same thing, they're pretty close because they even said that that 20.2 has been rounded to 3 significant figures. So this shows it as well, either way. All right, in our final part of example 3, part B, calculate the area of triangle ABC. So we're looking for this whole area. So we already know that angle A is 20.2 from our previous part. That means I can easily find angle B if I wanted to go that route by subtracting the two angles I have from 180. And I get 116.1 degrees. And I'm suggesting to go that route only because those are the two sides they already gave you. And finding angle B is going to be easier than finding side B. So now I can find the area using side C, side A, and angle B. And so I adapted my formula from the formula booklet, I subbed in everything that I have, and going to my calculator, still in degree mode, I have 2,245 square meters. Or to 3 sig figs, I could say I have 2,250 square meters. Both are acceptable.